Possibly, or at least get a start on the third lesson, because these aren't big lessons today. The next lesson is kinetic and potential energy. But, I mean, after the one we're doing now. Conservation of energy. Please write down. Okay. Got this? Yeah. Okay. Take a picture of what? Of what? Of what?
The homework.
But you have it on Moodle. Conservation of energy. Got this? You wrote this down? Yep. Okay. So, what is energy? That is, if something has energy or is energy, then what do we mean? So I know energy is a word that you know from English, or at least most of you know from English. So what is energy when we say something has energy? What are we saying? Huh? Yeah, like power, but more...
Has the potential to do something.
Getting closer.
Have some kind of charge.
Oh no, we're getting further away now. No. Further away. So energy...
is work done.
It is not, that's work. Work done is work done. What's energy? No, force is force.
That is the thing needed to do the work.
There we go. In physics, something has energy if it has the ability to do work. This is the definition of energy. Write it down. Nobody gave it to me, so everyone should be writing it down perfectly.
So, which part is the definition?
This, in physics, something has or is energy if it has the ability to do work. Okay, yeah, continue. Continue?
Yeah.
Yep. It's also measured in joules. So you also measure energy in joules. No work means no energy. No energy means no work. So if something has no energy, it can't do any work because it needs joules to do the work. If something doesn't... The point I'm trying to make is you need energy to do work. They go together. The work done is always less than or equal to the energy available to do the work. So for example, look. If I have 1,000 joules of energy, this means I can do up to 1,000 joules of work. Doesn't mean I do all the work. Maybe I do 100 joules of work or 200 joules of work. The work is always less than how much energy you have to do the work. It's like a tank. You know, you maybe have 1,000 joules of energy, and when you do work, this reduces. Like a car. You know, you fill the car up with petrol, and then the car drives and it reduces. Okay? So work is always less than energy. Yes.
So it's like if I'm hungry I can study.
Yes, that is true.
Are you hungry right now?
Yeah. And if I am hungry, I can't teach. Yeah. Now, for example, if I have 1 megajoule of energy, then I can do up to 1 megajoule of work, but I cannot do more than 1 megajoule of work. Often, problems we look at, all the energy is used doing the work. So usually when we look at a problem in physics, all of the energy available is used to do the work. So this means that often I use work and energy as the same thing, because usually all of the energy has been used to do work. So if you switch between using the word work and energy, normally that's okay, but not always. Normally it is. You understand? Yeah. Okay. There are many types of energy. That is, there's many types of things that can do work. Let's have a look at the types of energy. The types of things that can do work. So you'll need to write them all down. The first one, electrical energy. This energy can do work. In fact, it's very important energy for day-to-day life. The first one is electrical energy. Got that? Next type, magnetic energy. Because the magnet can lift the metal at the junkyard, as an example. So we have magnetic energy. So magnets can do work. So they have energy.
And isn't it like a magnetic force?
It doesn't matter what, it doesn't matter what the force is, but that is the force that's doing the work over the distance. Work is force by distance. In this case it's a magnetic force, but that doesn't matter. Next, you got this? You're writing all these down, magnetic energies next? You got that? Yeah. Okay, next one. The most delicious type of energy, and personally my favorite type of energy, is chemical energy. The cake has energy. When you eat the cake, you have the energy.
Yep.
Yes, you understand? Yes. Okay. Chemical energy. Now, it's not just food, of course. You might have done other
Experiments. Yeah.
yes, it could be food or drink. Yes, but also you've done chemical reactions in chemistry. Have you done any chemical reaction that releases energy?
Ionization.
Oh, you've done these exothermal. So which one releases the energy? Heat energy. Exothermal. So that's an example of chemical energy. Because that was that came from the reaction.
So is it exothermal to do with heat?
Yep.
Heat is energy.
And heat is, I spoke before I got to the slide, heat is a type of energy as well. So the next one, radiant energy, is the energy you get from like sunlight. It's not just sunlight, it's other things too, like radio and X-ray and all this, but it's radiant energy would be like light energy. Yeah? You got that one? Are you checking the dictionary?
No, I'm showing you a photo.
Is this one of these very demotivational posters you're showing me?
No.
Yes?
It's not between, like, here's about heat.
Yeah, it's different about heat. So this is not a heat energy. This is energy from the light.
What the photo actually shows.
Oh, good. Okay.
Isn't the energy that's used in the microwave?
Yeah.
Is it?
Yeah. Yeah, it is. Got that?
Yeah.
Okay. Next one is nuclear energy. Okay. What's that? Example is this. You don't have them in Vietnam?
I don't know.
They use a material like uranium. Do you know uranium? Plutonium?
Radioactive materials. Dangerous things.
Second wars.
Yeah, what's a Hiroshima, isn't it?
Yeah.
You know this Hiroshima in Japan?
Hiroshima, Nagasaki.
Yes. This is nuclear energy. This explosion,
Yeah.
this
Yeah,
bomb.
but it's also like chemical.
It's like chemical, but it's much, much stronger than chemical. It's a different thing to chemical. Yeah. It's like chemical, but it's different. It's stronger than chemical. Okay, continue. Yep, nuclear energy. Next, ionization energy. Now, you've done ionization in chemistry. Yep. So you have ionization energy. So you know, to free an electron, you need to give it energy. Yeah, yeah. So there is some energy at play here. The electron doesn't sit here. You have to free it. You have to give it energy.
Exciting.
Yes, yes. So there's ionization energy. Next, elastic energy. Got this one? Elastic energy. Gravitational energy.
You can go on and on with the examples.
And I will, thank you. That is an excellent idea. Gravitational energy. You got that?
Yeah.
Heat energy. Look, what are you complaining about, Faisal? All you're doing right now is looking at pretty pictures and writing words down, okay? So, it gives you a bit of a mental break. Yeah? Continue. Mechanical energy. You know, like when you wind the clock. Next, wave energy. How many have we done so far? 11? Okay, 91 to go. Next, kinetic energy. This is the energy something has if it's moving. A movement energy. Yeah.
It's an almost everything.
Yeah.
Unless it's not moving and it's potential energy.
Yes. Next one. Continue.
Yes.
Next one is potential energy. This is the energy stored inside of it. Like here, the rock has potential energy because it can just about, it can do work. It can kill this man here. So there's energy stored inside of it because it's about to fall. It has this ability to kill him. Yes?
And
Well,
the ability to move away.
Yes, he does.
Wasn't that gravitational?
Yeah, it's gravitational, but it's a tiny bit of a, well, firstly it's a different formula, and it is the same thing as gravitational, really.
NGH.
Yeah, but it's not, but this potential energy is not only for gravity. There are other situations where we have potential energy like this, but there's no gravity, which we'll see in semester 2. Okay, next. Definition. So conservation of energy is the most important
I know.
idea in physics. Now, do you want to give it to me?
Yeah.
Go on.
Energy can neither be created nor destroyed. It can only change from one form to another.
Good. I still want you to write it down though. Conservation of energy. Energy can neither be created nor destroyed, but it transforms from one form to another. It's a classic. From one form to another. So, I'm sure you've seen this in basic science class. You can't, well, I'll wait for you to write it down.
Why not have wind energy?
What?
Wind
Yep,
energy.
there's so many. I didn't include them all. There's hundreds. Yes, you have wind energy. What else do you have? Wind energy. What else did I not say? Well, radiant energy. So sound energy. What? Geothermal energy. Yeah, okay.
Do you have to memorize it?
No.
What's that?
I'm just trying to expand your vocabulary, huh?
Okay, what does your heart say?
What does he want?
What does his heart say?
Oh, yes. Yeah. His English is quite good. So, did you learn any new words from those pictures? No? Radiant?
I've seen them all.
You knew radiant energy? Okay.
Radioactive.
Yes, okay, fine. Now, what does this mean? Energy can't be created nor destroyed. Fuan, what does this mean?
It's just transferred, not decided by create or destroy.
Yes, just transfer.
Yeah.
So, for example, if I do some work, where did that work get its energy from? From me, yes. But where did I get it from?
Your muscle.
And where, chemical. And where did I get that from?
Your nutrients, your food,
Food. And where did I get that from?
from the plants,
And where did the plants get its energy from?
from the soil.
Sun. The soil or the sun, yeah. So,
About the sun.
where did the sun get its energy from?
He,
Mm.
it had it from the beginning of time.
And where did that energy come from?
God.
Yes. As my physics teacher used to say when you would ask him, and so where did the sun get its energy from? And he says, I don't know, ask Jesus. I don't know. He wasn't being serious when he said that. So you realize, if you're saying that you can't make energy comes from something else, then of course it leaves you with the question, where did that come from? Where did that come from? Where did that come from? So yeah.
Like in the beginning of time, there was so much energy stored in Earth.
Yeah, but where did that come from? Yeah.
Chemicals, all the gases that make up the planet.
Yeah, but where did that come from?
So final answer, where is the final answer?
Yeah, so if you're interested, you have to. Yeah, you have only. If you're interested, you have only 3 explanations. Okay. The energy that you have today came from something that has no start, back to minus infinity. That's one explanation. The second one is that the energy just came with no explanation. That's a possibility. So in other words, we got the energy from some point in the past, and where that came from, we simply have no answer. Or the energy suddenly appeared in the past, but it came from the outside.
Outside of what?
Yeah, no, outside of what? So if you want, you can go with God, if you're that way inclined. If you're not that way inclined, other explanations is from another universe. That we are only one in a smaller part.
But
So
then we always have to go back to that.
I know. So where does that come from? So
Still, it's not like the sun is not going around this mode.
Yeah.
This mode doesn't give her energy.
yeah, but where? Yeah, it does. But where did this energy come from? See, this is the question. You can always ask, where did that one come from? Well, where did that one come from? Where did that one come from? Do you know? So this.
We don't really care.
We don't really care. We just know from now on our energy can only change into something else. We cannot make more of it, we cannot make less of it. We have what we have and we can only change it. Okay? So, like I said, you could ask Jesus, or, well, not like I said, like the physics teacher said, or some other authority. But for physics, We don't know. We don't know where this energy came from. We just know we cannot change it. We cannot make more of it or less of it. We can only change it into different forms. So we have the sun. The sun gives energy to the plants. The plants give us energy when we eat it. And then we can do some work. That's the idea.
And take the energy out in the end.
Yeah. Some energy is released at the end as well. Yeah. And that is true. When we eat something and take energy and use this energy to do work, we do not use all of the energy. Some of it is released.
Most of it.
No.
Some of it is released, and some animals and insects would then take the energy from that,
Yep.
like flies
And plants.
and plants. Yes, if it was put back into the earth.
And
Yes.
then you eat
And-
plant again.
So we're basically eating.
And the circle of life is complete. Yes. Okay. So we already had a discussion on this only one question. And when you stand up and sit down, you've done work. Where has this energy come from? Where does that energy come from? And that, etc. I think we discussed in great detail this question here. Okay. So what we'll do is we'll have a start of the next lesson, but we'll only get a couple of slides done. Okay.